Desktop Commander MCP gives AI local terminal and file tools, but the real skill is using that power safely. Let's begin with what Desktop Commander lets AI do. Desktop Commander MCP gives an AI assistant controlled access to terminal, files, search, previews, and code edits. The payoff is simple. The assistant can inspect a local project, run safe commands, preview files, and suggest focused edits. But that power also makes the setup security sensitive. This video explains the workflow using a local demo workspace, not live business data. By the end, you will understand what the repo does, how it connects, and how to try it safely. By the end, you will understand what the repo does, how it connects, and how to try it safely. That sets up why developers are paying attention. Many AI coding tools can explain code, but they often need help seeing the full local environment. Desktop Commander connects an MCP-compatible AI client to filesystem and terminal tools. That can help with codebase exploration, documentation, data analysis, and focused code edits. The repo also includes audit logging and security hardening features. The useful mindset is powerful local tools, controlled by clear boundaries. With why developers are paying attention in mind, the next piece is high-level architecture. The architecture has four main parts. First, the AI client where the user asks for help. Second, the MCP client layer that connects to external servers. Third, Desktop Commander as the local MCP server. Fourth, local tools for terminal, files, search, previews, edits, and logs. The AI requests a tool call, the server runs the tool locally, and the result returns to the chat. That idea leads directly to use a demo workspace first. Because this repo can interact with your local machine, the safest first test is a demo workspace. Create a folder with sample files only. Use names like samplereport.md, demodata.csv, and app.js. Ask the AI to list, read, and search only inside that folder. This keeps the first demo useful without exposing private files. Once use a demo workspace first is clear, installation options becomes much easier to understand. The README shows several install paths, including npx setup, manual config, local checkout, and Docker. For a quick demo, npx setup is the simplest path. For stronger isolation, Docker is the safer path to discuss and test. The right choice depends on how much host access you want to allow. The install step matters because it decides how the MCP server runs. From there, the next practical step is manual MCP configuration. The MCP config tells the AI client how to start Desktop Commander. The command is npx, and the package is at wonderwhy-er/desktopcommander. This is a standard MCP server entry. After adding the config, restart or reload the AI client. If the server appears in the tool list, the connection path is working. This sets up the next important point, Docker isolation option. When a tool can run terminal commands or touch files, isolation matters. The README includes Docker installation as an option for sandboxing. A basic Docker run keeps the server inside a container. This is useful for testing without giving the tool broad host access. Docker is not magic, but it is a better starting boundary than full host access. Docker is not magic, but it is a better starting boundary than full host access. That sets up mount only what you need. If the container needs files, mount a specific demo folder. Do not mount your full home directory for the first test. A folder like /demo_workspace is enough for learning the workflow. This makes the boundary visible and explainable. The AI can work with demo files while the rest of the machine stays out of scope. With mount only what you need in mind, the next piece is first safe workflow. The first useful prompt should be read-only. Ask the assistant to list demo files, read one sample report, and summarize it. That tests terminal/file access without modifying anything. It also shows whether the model respects the folder boundary. A good first workflow proves connection before automation. That idea leads directly to read file preview. Desktop Commander can read files and show previews for supported formats. For a demo, start with a small markdown file in the workspace. Use line limits so the assistant receives only the needed content. The important idea is not reading everything. The important idea is giving the model the right local context. Once read file preview is clear, search the demo folder becomes much easier to understand. Search is one of the most practical capabilities in this repo. Instead of opening files manually, the assistant can look for names or content patterns. A safe example is searching to do inside the demo workspace. The result helps the AI decide which files deserve attention. Search turns the local folder into navigable context. From there, the next practical step is focused code editing. Desktop Commander supports search and replace style edit blocks. This is useful because small focused edits are easier to review than full rewrites. The demo edit changes one line in a sample app file. The viewer should understand the behavior before copying the format. For real projects, always review the diff before trusting the change. This sets up the next important point, structured files and previews. The repo summary highlights support for structured files such as Excel, PDF, and docx. That makes the tool useful beyond code files. A demo could preview sample invoice 001.pdf or demo_data.xlsx. Keep this educational and fictional. The key idea is that local documents become readable context for the AI. That sets up process and session control. Desktop Commander can also work with running processes and long-running commands. This is useful for local dev servers, test runners, and REPL workflows. A safe demo is starting a local test server and reading its output. Avoid broad system commands for a first tutorial. Process control is powerful, so it belongs inside a controlled workspace. With process and session control in mind, the next piece is audit logs show what happened. A good AI tool workflow needs traceability. Desktop Commander logs tool calls with timestamps, tool names, and sanitized arguments. Those logs help with debugging and security review. They also show the difference between what the AI said and what the tool actually did. For tool using agents, logs are not optional, they are part of the engineering workflow. That idea leads directly to configuration controls. Configuration is where safe usage starts becoming intentional. You can inspect settings such as blocked commands, default shell, allowed directories, line limits, and telemetry. Use a separate configuration chat or session before real work. Set narrow allowed directories instead of broad file system access. Then verify the configuration before starting a task. Once configuration controls is clear, allowed directories gotcha becomes much easier to understand. The README warns that allowed directories currently restricts file system operations, not terminal commands. That distinction is important. A shell command may still access paths outside the file tool boundary. So allowed directories is useful, but not complete isolation. For stronger separation, use Docker and mount only the demo workspace. From there, the next practical step is telemetry and privacy. The README says telemetry is limited and pseudonymous, and does not collect file contents, paths, or command arguments. It also gives an opt-out path through configuration. For a tutorial, show the privacy setting without turning it into the whole video. The bigger habit is simple, use fictional files and avoid private data in prompts. Privacy starts with what you choose to expose. This sets up the next important point, troubleshooting the first run. If the server does not appear, check the MCP config location first. Then check whether node, npx, or Docker is available from the client environment. If tools appear but fail, inspect recent tool calls and logs. If file access fails, check allowed directories and mounted folders. Debug the connection path before debugging the AI answer. Debug the connection path before debugging the AI answer. That sets up safe demo output. A successful first demo should produce a boring, safe result. It should list demo files, read a sample report, find a few to-do items, and make no changes. That proves the server works without risky automation. Once the basics are reliable, you can test a small edit on a sample file. Each capability should be introduced one step at a time. With safe demo output in mind, the next piece is where it fits in a real workflow. Used carefully, Desktop Commander can support codebase exploration, documentation, local test runs, file previews, and focused edits. For teams, the adoption path should start with read-only exploration. Then add restricted edits in demo branches or sample folders. Only later consider broader workflows with approvals and backups. The repo is powerful because it brings local tools into AI workflows. The discipline is controlling the scope. With where it fits in a real workflow in mind, the next piece is final recap. Desktop Commander MCP connects an AI client to local terminal, file system, search, preview, editing, process, and logging tools. The core architecture is AI client, MCP layer, local server, and local tools. The safest first demo uses a sandbox workspace and read-only tasks. Docker isolation and narrow mounts reduce host exposure. Audit logs, configuration checks, and focused edits make the workflow easier to trust. The takeaway is simple: powerful local agents need practical boundaries. To wrap up, here is the key takeaway. You now have a structured overview of Desktop Commander MCP explained. Give AI terminal and file control safely. Review the core ideas, connect them to examples, and revisit concepts like what Desktop Commander lets AI do, why developers are paying attention, high-level architecture when practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.